All right, this is chapter 8b, and so we're going to do the second half of the chapter dealing with mostly logarithms and logarithmic functions, right? So 8b, logs and logarithmic functions. All right, let's get right into it. If you're going to understand logarithmic functions, you have to understand how they relate to exponential functions. So you can see here I've got an exponential function y equals 2 to the x. And I've graphed that function there in black. And we've done this in the first half of this chapter. And so we know how to graph logarithmic functions, xy chart, asymptote of y equals 0, etc. It's a growth and all of those things. Now, a logarithmic function is its inverse. It's its inverse. If you take a look, notice that where you have y, we now have x. Where you have x, we now have y. And so it's the inverse. All right, we talked about inverses. We said that they are mirrored about a 45-degree angle. So I've included that reference line there, that 45-degree angle. And so using the points and the inverse, we can graph it. So if you'll stay with me here, I'm just going to go point by point. So here's that first point. And that's really -2, and that's 1/4. So therefore, it would be 1/4 -2. Right about there. Second point is -1 1/2. So we'd be at 1/2 -1, which is right there. Next point, 0 1. So now we're going to be at 1 0. Next point, 1 2. So we're going to be at 2 1. Next point, 2 4. 4 2. And finally, the last point is at 3 8. So we'd be at 8 3 if we were able to draw that. Now in this case, the y-axis is going to be the asymptote, because we have an inverse here. And so it's going to approach that y-axis. And there is the mirror image of that function. All right, so logarithmic function is the inverse of the exponential function. If you look in domain and range here of this, the domain would be x greater than 0, right? X greater than 0. There are no x values 0 or less. So x is greater than 0. The range on this would be all the real numbers. And though the function is heading to the right a whole lot more quickly than it's going up, again, remember it has forever to go up, and therefore it does reach positive infinity as far as the range goes. Okay, to help you understand logarithms, you should get into your brain and into your head and into your thoughts that logarithms are exponents. Logarithms are exponents. You need to keep that in mind all the time. Logarithms are exponents. I'll show you that more as we go along, and as each concept comes along, you'll see that borne out. But get that in your thoughts and try to keep it there. It really is a key concept. All right. What's the purpose of logarithms? All right. There are many. When you talk about earthquakes, the Richter scale is a logarithmic scale. When you talk about pH, acidity, is something acidic? Is it basic? Is it alkaline? That's a pH scale. Hearing, decibels, right, and such. That's a logarithmic scale. So there are lots of real-life applications of logarithms. Mathematically, a big purpose is to be able to solve equations where the variable is an exponent. So currently, we have no means of solving this equation, 7 to the y equals 52. Now, I know that y is somewhere a little bit bigger than 2, right? And I'm looking right here, because I know 7 squared is 49. And now I'm close, 49 equals 42, I'm close. So maybe is it 2.1? And I can sit there with my calculator. I can play with my calculator, play with my calculator, play with my calculator, and play with my calculator. But I know y is 2 point something. I don't know, 2.01, 2.1007, 2.201395. I don't know. I can play forever. I can get close, but I need an exact value. And logarithms will give that to me. Now, you don't know how to do this yet, and we will in a little bit. But if I solve this problem, the log of 52 divided by the log of 7, and I can just simply take my calculator out and punch these values in, and my calculator tells me the value of this is approximately, I have to round off but here's the value, 2.030537597, etc. Now, again, I know I used the word exact value, but the calculator is holding the exact value. And if you were to take 7 as a base, use your exponent button, punch in 2.030537597, you're going to see that your calculator is going to tell you 52. All right, so logarithms. What are they? They're exponents. What's a main value mathematically? That is to solve for when the variable is an exponent. Okay, so logarithms. Number 3, very important. Number 3. To understand logarithms, you must learn to convert between logarithmic form and exponent form. You have to be able to convert between the two. Okay, so you don't think well in logarithmic form. Okay? Right here on the left, you got logarithmic form, y equals log, really, of x in base b. Y equals log of x in base b. You don't think well that way. You just don't. You don't understand what that means. So we have to, in our minds, convert it to exponent form, and it'll make a little bit more sense to us. So here's how it goes in exponent form. Grab your green. B is the base of the exponent. Now, I told you earlier, logarithms are exponents. So the y equals this log of x in base b. So therefore the y is the exponent. The y is the exponent. So it's b to the y equals x. B to the y equals x. Logarithmic form, exponent form. And you have to be able to go between both. You should be able to switch things in exponent form to logarithmic form and things in logarithmic form to exponent form. And that's really what today's lesson focuses on, because this is the foundation of understanding and doing all logarithms. You gotta understand what they are and how to go between the two forms. Exponent form, we understand, we've been dealing with it since pre-algebra. Logarithmic form, brand new. And we have to now begin to get an understanding of just what logarithmic form is. Okay? All right, so again, don't forget how to read these. Y equals the logarithm of x in base b. So of x in base b. All right, let's do some changing here. Get rid of my shade. Let's see if I can go a little higher. Let's keep that at the top. Okay, so let's go through. First couple are color-coded. Should make life easy. All right, so again, I'm looking right here at A. If you'll focus your attention there. 4 equals log of 16 in base z. Now, that doesn't mean anything to us. It doesn't mean anything to us. However, if we were to convert this to exponent form, it might begin to make some sense to us. Z is the base. Logarithms are exponents, so the exponent is 4. And it equals 16. Do you know the value of z? Do you know the value of z? Well, you should. We did these last chapter. All right? If I wanted to solve this, remember I can change a 16 to 2 to the 4th. Therefore, z equals 2. right? Z to the fourth equals 2 to the fourth, so Z must be 2, right? And that is the case. Z is 2. But we switch between logarithmic form and exponent form, and now we actually understand what's going on. All right, take a look at the second one here to the right, B. All right, we have y equals the log of 9 in base 3, or the log of 9 in base 3 equals y. Right? You can left side, right side, symmetric property, not a problem. All right, let's convert that. So that's the base is 3. The exponent is y, and it equals 9. No sweat understanding the value of y now, is there? Everybody knows the value of y is 2, of course, right? Because 3 squared is 9. All right, so now we know the value. So we took something we had no clue what it was, and we actually know the value. Y is 2. Third example, right? So go ahead and convert it. I'm going to pause. You should pause your video because I'm going to pause, and if you don't pause, it's just going to keep going in your estimation, okay? So pause the video, go ahead and do it, and then restart the video. Okay, so hopefully, again, you looked at the base, and you said the base is 11. The exponent is the negative 3, and it equals x. And you could actually punch this out in your calculator, or you could change the form because we understand what negative exponents are. And in reality, x equals 1 over 11 cubed, and that's going to be, I think, 1,331. 1 over 1,331. All right, go ahead and pause again, do D. Go ahead and convert it. All right, and hopefully you said that D was 7 to the 1 equals A. So what is A? 7, right? 7 to the 1 equals A, so A is 7. All right, how about this last one? How about E? All right, we don't show it equaling something. You'll have to come up with your own variable, right? So it'd simply be 5 to, I don't know, I'll use N equals 97. 5 to the N equals 97. Can you approximate the value of N? It's not a 2, right? 5 squared is 25. But it's not a 3 either. 5 cubed is 125. So somewhere between 2 and 3, probably a little closer to 3 than the 2. All right? And again, we'll learn how to solve that as we continue on in the chapter. Logarithms are exponents. You got to be able to switch between the forms. Okay? So we just went from logarithmic form to exponent form. Let's go back the other way now. Let's go from exponent form to logarithmic form. Exponent form to logarithmic form. Again, I've got this first couple color-coded. So 7 is our exponent. LOG for logarithm. What is the base? It is the x. And so of 95. And again, what do we have? 7 equals the log of 95 in base x. Right? 7 equals the log of 95 in base x. All right? Go ahead and pause and do B. All right, and so hopefully with B, you said x equals the log of 1 in base 13. All right? B equals the log of 1 in base 13. All right? And again, I would, if I were you, pause, I'd do C and D, but you've got to know how to do these. You've got to be able to convert. Got to be able to convert. All right, C. So logarithms are exponents. Y equals the log of A in base 5, right? Y equals the log of A in base 5. Logarithms are exponents. So 5, the exponent, equals the log of n in base z. 5 equals the log of n in base z. You have to be able to do this. You have to keep these straight. You should get these correct 99.9% of the time. Now, I'm not trying to be mean. I'm just trying to say there's 3 or 4 or 5 of you where you're not going to fully understand how to do this. Now, this is just a pattern that you learn, and you're not that great with patterns, and I can understand that, and I sympathize with you there. However, you can learn the pattern if you'll spend some time with it. You have to spend the time to get the pattern down. If you don't understand how to go between these two forms, you'll be lost the whole rest of the chapter. So get this down tonight. Get it down now so that you're able to do these. Very, very, very important. Because we're going to apply it right now. So let's do the next section here. And let's apply what we've just learned. Okay, let's evaluate each. So here you have log of x in base 5 equals 3. What's the value? I have no idea. Well, maybe we do. Let's go ahead and change the form. The base is 5. The exponent is 3, and it equals x. Oh, I can do this on my calculator. 5 cubed is 125. I just evaluated it. Okay? So by changing the form to exponent form, I was able to figure out what in the world's going on. All right? Try that with B. Again, pause if you want to, and see if you can work it out. All right, so what is our base here? X. What is our exponent? -2. What does it equal? 1/16. Okay, if you're going to solve this, you'll have to think of this. You'll have to think of 16 as a 4 squared, right? And let's use the negative exponent rule. So 4 squared in the denominator is 4 the -2 in the numerator. Being the exponents match, x must equal 4. Okay, that's a little tricky. A little tricky. You might say, well, you know, Mr. Scarfi, we could have just as easily made 16 a 2 to the 4th. Yeah, we could have, but then I wouldn't have gotten the exponents to match, and I needed the exponents to match. Okay? So I chose to have a 2 exponent because I could, so that way they would match. See, that's tricky. I would have never thought of that. I know. That's why I showed it to you. Okay? How about this next one? So again, we're going to change the form. It's going to help our understanding. The base is 2. We do not know the exponent, but we know it equals 16. Now notice in this one, I want to get the bases to match. So this time I'm going to change the 16 into a 2 to the 4th. Now remember last chapter, since the bases match, n must equal 4. Okay? A little bit different situation. Look at the difference between this one and the previous one. In this one, the variable was the exponent. Therefore, I needed the bases to match. In this one, go back here, the variable was the base. Therefore, I needed the exponents to match. It's a subtle difference, but that is the difference. And that is what you're looking at. Okay, do D if you can. D if you can. My base is 8. My exponent is x, and it equals 2 to the 6th. Ugh. What in the world are we going to do on this one? Not a problem. Not a problem. 8 is 2 cubed to the x, right? Equals 2 to the 6th. Let me move to the right here. So right now I'm at 2 to the 3x equals 2 to the 6th. Therefore, 3x equals 6. And guess what? X is 2. Okay? Wait, look, honestly, we've done these last chapter. Working through exponents. Okay? All right, so evaluate. You'll see some of those in your upcoming homework. All right, let me deal with one last aspect here. And let me extend my page. And so let's look at number 7. All right, we have graph y equals 2 times the log of x plus 3 in base 2 minus 1. All right, There's a couple things going on here that we're going to have to deal with. First off, to graph this logarithm, I need to graph its base equation, the exponential equation. Because remember, as I introduced this lesson, I told you that logarithms are the inverse of its exponential. Okay? So, I'm taking its base 2. Right? So if I just take y equals log of x in base 2, I'm going to convert that to exponent form right there. And that's the first thing I need to graph and first thing I need to deal with. Okay, so if I'm going to graph x equals 2 to the y, what I'm going to do is I've got to work backwards. X equals 2 to the y. I got to work backwards. Instead of filling in the x's for my xy chart and getting y, I'm going to fill in my y's to get x. It's just because the y is the exponent. Okay. What's 2 to the negative 1? And hopefully you say 1/2. So we have the point negative 1, 1/2 right there. All right, what is 2 to the 0? 2 to the 0 is 1, and we have the point 0, 1 right there. Now, again, you can pause the video at any time if you need help. 2 to the 1 is 2. So we have the point 1, 2. And 2 squared is 4, and we have the point 4. 2, 4. Okay. Now, that's my base pattern. It's my base pattern right now. And so I've got to work off of this base pattern. All right? It's my base pattern, and off of it, I've got to do the rest of my work. Now, I've got this 2 out in front of the logarithm, and it's the a value. Remember, we've talked about this. So this is a multiplier. So now I have to multiply times 2, and this shouldn't be x. This shouldn't be y. This should be x. Tricky, tricky, tricky. Okay, so I don't know. Hopefully you're not drinking the Kool-Aid. Oh, you got to be careful when you switch your x's and y's because it's very, very easy to graph them backwards, and I just did that. So if you caught that as we were going along, good for you. You weren't drinking the Kool-Aid and you were thinking. But, you know, when you input a y to output an x, you still have to graph it xy. All right, and I did yx. It's easy to do. Be careful. All right, so let's go back to our xy chart right here. And let's graph these points. 1/2 negative 1 is right there. Better. X of 1, y of 0 is right there. X of 2, y of 1 is right there. And x of 4, y of 2 is right there. That's what we need. Okay? All right, feeling better? Now we've got to do the multiplier. So we have a multiplier of 2, and this is going to change all of our y values. It's going to change all of our y values. So it is y. And so we're going to multiply times each y. So this negative 1 now becomes a negative 2. You follow? So we're going to multiply each time. Here, I'll leave that. Negative 2. This is still 0. This is 2, and this is 4. So now in blue, I'm going to do those points. 1/2 negative 2. 0, 1 is still 0, same place, right? 2 is now 2, and 4 is now 4. Okay, now we're working off the red dots, all right? A little tricky, I know, but that's okay. And now we have to work off of third, move each point by a factor of hk. What's the value of h? Look, we've learned this. Go back to the parent function. Now you're looking here, right? What is h? -3, right? And what is k? -1. Now we have to take every point 3 to the right and down 1. We have to take every point 3 to the right and down 1. 3 to the right, down 1. 3 to the right, down 1. So working off the blue points, we'll do this in green. Go 3 to the right and down 1. And I don't like that point. That doesn't look good to me. I don't like that. It's bothering me. 3 to the right and down 1. Definitely don't like that. All right, let me hold on a second. Let me think for a second. Okay, sorry to make them so complicated. So let me go back here and I'll just clarify here. So -3, this is left 3, and this is down 1. So again, we're going to take every point, we're going to go left 3. So I'm going to go 1, 2, 3. And I'm going to go down 1. Left 3 and down 1. Okay? Go to the second point here at 1, 0. And go left 3 and down 1. And we're right there. Take now the next point at 2, 2. Go left 3 and down 1. We're translating this function now. Let's take our last point at 4, 4. Go left 3 and down 1. And here's the graph of this function. All right, took me a while to get there, but that is the function. So let me go back and recap what we did here. What we did was, first off, we took the base function, y equals the log of 2 to the x, so the log of x in base 2. And we changed it to exponent form. Because the variable, the base is to the y, we switched and did the put in values for y to figure out values of x, and we plotted those points and they're in red. Next we had to deal with the multiplier, the a value. And so that 2 multiplier, we had to multiply the output by 2 in every situation. So we took the y value and we multiplied it by 2. So -1 times 2 is a -2, etc. And that gave us the blue points. The blue points now have the base function and the multiplier cared for. The last thing we have to do is a translation. How is this thing translated? It's translated 3 to the left and 1 down. Therefore, every blue point had to go 3 to the left and 1 down, and there it is. Now, you could also do this exact same thing with just an XY chart in your calculator, but you'd have to figure out how to deal with the log, and you're not going to know how to do it. So this is the methodology you're going to have to use. Okay? So again, you can go back and rewind. I know I goofed it up a couple times, so let me one more time recap how you would graph a function like this. First thing you're going to do is you're going to do the base function. Right? There it is right there. And therefore it gives you, you're going to switch it from log form to exponent form. The base 2 to the exponent y equals x. You now need to come up with the points in an XY chart. However, instead of choosing values for x and finding out the y, choose values for y to find the x. That gives you those starting red points. If there is a multiplier, do step 2. If there's not a multiplier, you don't need step 2. This one has a multiplier out front, right? That 2. Therefore, we've got to do step the second step, and multiply each y value, each output, by 2. That gives us the blue points. Now, lastly, do the translation, h and k. If there's only an h value, only move the points left or right. If there's only a k value, only move the points up or down. In this case, we had both. We had to go both left and down, and that gave us the curve. All right, I think you can do that. Remember, logarithms are exponents. You must keep that in your mind at all times, and you must get down how to switch between log form and exponent form. So, going both ways, convert it from log form to exponent form, and from exponent form to log form. If you can do that, then you'll lay the foundation you need for this lesson. All right, have a great day. And oh, by the way, day off tomorrow and a weekend coming, so in actuality, you guys need to do the homework there at the bottom of the page, and that is due on Monday. So homework is due on Monday. All right, enjoy your weekend.